Welcome to the video for section 2.3 in Algebra 1. It's multiplying and dividing rational numbers. Before we begin though, did you hear about the cat who swallowed a ball of yarn? Well, she had mittens a few days later. So, if we're going to multiply two rational numbers together, like we have the expression 3/4 times 7/8. What exactly do we do to multiply fractions together? Now if you look in their book, there's some math theory in here that I'm just really not going to go ahead and get into. We have limited time in homeschool co-op class, so we're just going to review the actual mechanics of how you multiply fractions. When you added fractions or subtracted fractions in the last video that we did, you remember that the denominator, or the bottom and the number in the bottom, had to be the same in order for you to add or subtract fractions. It's not that way with multiplication. You're going to multiply together two fractions and take the form a over b and c over d, where a, b, c, and d are integers. Actually, it can even be real numbers, but b and d can't be equal to 0 because you can't divide by 0. But you have two rational numbers that you're multiplying together. That's equal to the product of the numerators, a times c, divided by the product of the denominators, which is a times d. So this just says we have one fraction times another fraction, or one rational number multiplied against another rational number. We write this as a single fraction, the product of the numerators, 3 times 7, divided by the product of the denominators, which is 4 times 8. 3, there's no factor of 3 in the denominator. There's no factor of 7 in the denominator. So we're going to take the product of 3 and 7 is 21. The product of 4 and 8 is 32. And this is the solution to the multiplication problem, 3/4 times 7/8. That's all there is to it. But you know what? This right here is in lowest terms because there are no common factors between the numerator and the denominator. Most of the time, however, when you multiply together fractions, you're going to have common factors in the numerator and the denominator that we need to deal with. Because if we don't remove those using our principle that says any number divided by itself is equal to 1, we don't factor out or cancel out those common factors, then we would have an answer, a rational number that was not reduced to lowest terms. In other words, it would have a common factor in the numerator and the denominator that you would have to remove. So what do? How do we deal with that when we have common factors in the numerator and in the denominator? So let's go ahead and look at this one here. Let's say that we have this problem. This is on the top of page 57. It's just an example. 43 divided by 31 times 31 divided by 74. Now this is very specifically selected to illustrate an obvious point. Now if we were going to just go ahead and use a rule that says when we're multiplying fractions together, we combine this as one fraction with the product of the numerators divided by the product of the denominators. You have to get your pencil and paper out since I've taken away your calculators. And you would have 1,333 divided by 2,294. And I can virtually promise you that in the scope of this class, if you have huge number divided by huge number, there's some sort of a common factor that's involved there. So you're going to have to go through and prime factor the numerator, prime factor the denominator, and then cancel out common factors. Well, hopefully several of you have seen, if not all of you, have seen that this was probably not the best way to go. At heart, but who wants to do the extra work in the math? Use your knowledge of how numbers work together, of how algebraic rules and principles and properties work to save yourself time and effort. 43 over 31 times 31 over 74. Now some of you are saying, okay, we've got a common factor of 31 here, and we can cancel out that factor of 31. And that's true. That's exactly what we're going to do. I'm going to manipulate things just a little bit to put just a tiny little bit of theory in here. I'm not putting all of it in that's in the book, but just a little bit. So if we have 43 times 31 in the numerator, 31 times 74 in the denominator, that's exactly what I did here. You use our commutative property of multiplication that lets you reverse the order of the factors. You have 31 times 43 divided by 31 times 74. 74. Now, if it's true that you have, I think I'll write it here, that property that says if you have A over B, see how I want to do this. A over B, I got distracted by someone walking past the door. Any number divided by itself is equal to 1, correct? Well, look at this. We have any number divided by itself. So we can say that this is 31 divided by 31 times 43 divided by 74. 31 divided by 31 is 1 times 43 divided by 74. 1 times 43 divided by 74 is 43 divided by 74, which becomes our answer. Now it's this process of thinking that allows us to cancel common factors. Aren't you glad we don't have to write all of this down? We know that because any number divided by itself is equal to 1, we can just immediately cancel common factors right there and write our answer, 43 over 74. So whenever it's possible, even though you can multiply first and then cancel common factors, whenever possible, you're going to want to cancel common factors prior to multiplying. It'll save you a lot of work. That's the biggest thing that we have in section 2.3. Let me work just these couple of examples. Example 2, 3/4 times 18/7. Okay? We can write this in factored form. 2 times 2 times 2 times 9 over 7. Now, your text will tell you to factor each of these numbers down into, to write the prime factored form. But sometimes you can just save yourself a little bit of time by realizing that, oh, I have a factor of 2 in common here that I can't cancel. And I have 3 times 9 is 27, divided by 2 times 7 is 14. I'm going to show this to you 2 different ways because everyone in this class is at somewhat of a different level. If you're still working, still struggling with how to cancel common factors by using fractions, this is what you want to do. You want to prime factor each individual factor write it as a product of primes. You know, you can do that 4, use your factor tree. 4 is equal to 2 times 2. And write that in exponential form. And then 18, we want to factor 18. Maybe you think of that as being 3 times 6. 6 is 2 times 3. So 18 is 2 times 3 times 3, or 2 times 3 squared. 7 is a prime number, and 3 is a prime number. You can only cancel factors that are in the numerator with factors in the denominator. Obviously, you can't cancel a 3 and a 3 here because they're both in the numerator. We have one factor of 2 in the numerator. We have 2 factors of 2 in the denominator. So we have one factor of 2 in common, which means that we've used one of these. We've gone down to 2. 3 times 3 squared is actually 3 times 3, which is 27. 3 times 3 times 3 divided by 2 times 7, which is 3 times 3 is 9 times 3 is 27 divided by 14. You see, of course, that you get exactly the same answer whether you actually go ahead and prime factor each individual factor here. Notice I'm using factor a whole lot, but there's not another word I can use. Or if you recognize that the only thing that you have in common here is a factor of 2 and you say 2 times 9. But you arrive at that answer the same way. So this was multiplying. Now what happens if we're going to divide? What we're going to do to divide a fraction, we have 1/2 divided by 1/3. You've learned way back starting in 5th grade that if you're going to divide fractions, that's the same as multiplying by the reciprocal of the divisor. You flip the fraction, multiply. It changes from a division to a multiplication problem, and your solution becomes 3/2. Very, very simple, very straightforward. But you also are going to want to get a little bit more vocabulary here. We talk about multiplicative inverses. What's a multiplicative inverse? Well, multiplicative inverses are this, and you'll need to make sure that you have this vocabulary under your belt so that you can tell me what a multiplicative inverse is. Multiplicative inverse. And the definition that I'm looking for is on the bottom of page 57. Multiplicative inverses, these are two numbers whose product is equal to 0. Whose product is equal to 0. Two numbers whose product is equal to 0. You probably think of a multiplicative inverse as the reciprocal. 3/2 right here is the multiplicative inverse of 2/3, because if you multiply 2/3 by 3/2, which is its multiplicative inverse, whose product is equal to 1, I'm not sure why I said 0, two numbers whose product is equal to 1. I apologize for that. I'm not going to go back and correct this video though. At the moment, two numbers whose product is equal to 1. It's equal to 6 divided by 6. Okay? The reciprocal of a number is what you think of when you're talking about a multiplicative reciprocal. It's also the multiplicative and multiplicative inverse of a number. Okay, make sure you get this. Make sure you've gone in and corrected in your notes. I wrote two numbers whose product is equal to 0. No. Two numbers whose product is equal to 1. I guess my mind had a Monday moment there. So let's look at this. A couple of examples of dividing rational numbers. Divide 4/5 by 9/10. Division is the same by multiplying by the reciprocal. The reciprocal, or the multiplicative inverse of 9/10, is 10/9. Now we could say this is 40 over 35, but we also can recognize that 10 can be written as a combination of factors of 2 and 5. Everyone see that? 5 is a common factor. 2 times 4 is 8 ninths. Is a solution to the problem 4/5 divided by 9/10. Things to remember are that division is the same as multiplying by the reciprocal. That's what that's going to have to look like. Okay? Now let's go ahead and do the third example here. Actually, it's example 5. It's the third one on page 58. And that one is 5/7 divided by 5. What's division? Same as multiplying by the reciprocal. What's the reciprocal of 5? It's not 0 over 5. See, 5 is actually 5 over 1. If you flip that, that becomes 1/5. You have a common factor of 5 that cancels. Your solution is 1/7. Okay? Then they have some review of multiplying decimals. What do you do when you multiply decimals? You multiply decimals and you add up the number of spaces past the decimal point, 4.28 times 5.31. Well, 4.28 times 5.31, you do that multiplication and you end up with 227,268. And what's the location of the decimal point? How many places do you have? 1, 2, 3, 4. So you need to have 1, 2, 3, 4 spaces after the decimal point when you multiply. And the last thing, you know how to multiply with decimal numbers, you know how to add, you know how to subtract. How do you do long division with decimal numbers? You should remember this also from a long time ago, and also from your assessment test. 1.26 divided by 0.3. Let's do this with long division. 1.26 divided by 0.3. When you're doing long division, you have to multiply by a whole number. So you move your decimal point to the right as many units, as many spaces as you need to for this to become a whole number. You move your decimal point underneath the division bar the same number of spaces. So this becomes 3 goes into 12. How many times? 12. Bring down the 6. So 1.26 divided by 0.03 is 4.2. And you think, boy, that's weird. I end up with a bigger number than I started with. Well, let me verify for you that that's actually correct. How do we do that? Whoops, I just erased it. I'll write it back up here. We had 0.3 to 1.26 is equal to 4.2. How do you check your work? You multiply these numbers together. 0.3, 4.2, 3 times 2 is 6, 3 times 4 is 12. Where do I locate the decimal point? I have 2 digits after the decimal. Decimal point is located right there, 1.26. So if you are still having trouble multiplying, dividing, adding, subtracting rational numbers, go back to Khan Academy. You can find out information about how to get onto Khan Academy, how to use it by looking on your ARC homepage. Go to the ARC website, www.ecoops.com/ARC. Sign in using your login information and your password. Go to your classes and then click on Algebra. And then here's your Algebra class page. This is the Algebra class page. And over here you have these links. There's one over here on the right hand side that says Khan Academy. If you're still having difficulty with rational numbers, click on the Khan Academy video, watch it, and use that to bring you up to speed so that you can continue on with us in algebra. You'll have a great day.